So the crate below is to be constructed using 36 feet of lumber. What is the equation that represents the volume of the crate as a function of x? So the first thing that we want to make sure we are aware of is what the question is asking us to do. The question is asking us to write a function for the volume in terms of x. So what that should trigger in your mind is that a function v equal to some expression in terms of x. And it's also very important to remember what we know. We know here that we are using 36 feet of lumber. What does it mean when it says we're using 36 feet of lumber? Let's start with that. Let's write down what we know, and I'm actually going to shrink this, put it off to the side here. What are we told when they say 36 feet of lumber? Well, they mean that the total amount, maybe I should make this slightly bigger. We're told that the total amount of lumber that we can use is 36. It needs to add up to 36. So let's write that here. We know that 36 will be the total amount of lumber. What represents all the lumber? Well, all of the pieces of lumber that I use, the length of all of those combined has got to equal 36. So how would I represent that? Well, let's use the variables that they give us. And let's just think about, well, let's start first with the height. So the height here is x, but this is not just counted once. I have one length x here, another length x here, another length x here, another length x here. So that's 4 lengths of value x. And then I also know that the length of my figure is x, so I have another x there, another x there, another x there, another x there, and altogether that's going to give me 8x feet, right? However many feet this one x is, I'm going to have 8 of them. And then I go to the y, and I have 4 lengths of length y, so then I'm going to have to add on 4 y lengths. And think about it, this is the total amount of wood that we will have, length of wood, and that's got to equal 36. And so now I can actually think about, okay, what am I going to do? How am I going to write an equation for the volume in terms of x? Well, what I'm going to do is I'm going to first think about, well, what do I know about volume? Volume is length times width times height, right? So what will I need to do in order to create a volume equation, but only as a function of x? Well, I know that volume is length times width times height, so in order to make it in terms of x, I need to know the length, the width, and the height in terms of x here. So let's just start variable by variable. That should be our plan, is to go variable by variable and write it in terms of x. So what about the length of our function? Can we write that in terms of x? Well, the length, there it is actually x itself. So that takes care of itself. We'll skip the width for a second. The height also happens to be x. So the first two are pretty easy. And then what's the width? Well, the width is y. And I'm actually going to write it here for just 1 second. The width is y. And so at this point we need to have a plan, kind of a secondary plan. What's going to allow us to, instead of having y here, to have something in terms of x? Well, now I've got to write y in terms of x. And what am I going to be able to use to do that? I have this other equation which has y and x involved, so I can write y, I can isolate y in terms of x. When I do that, I'm going to get 36 minus 8x all divided by 4. I can simplify that further. That's just going to be 9 minus 2x. So I know that this is y. Perfect, because that's what I needed. So the volume of my crate will be given by, and I'll just take x times x and make it x squared times 9 minus 2x. There we go. So I have now a function that represents the volume in terms of x. And you might be tempted to go ahead and multiply, distributive property, and you can do that. And in fact, maybe let's just do that now. So let's go ahead, we'll have two forms. So when we multiply this in, when we distribute this in, remember the biggest degree we're going to get is not from the x squared minus times 9. It's going to be from x squared times negative 2x. That's going to give us negative 2x cubed. And then x squared times 9 is going to give us a positive 9x squared. And so both of these versions of our function are going to be very helpful, because the next thing that we're asked to do is we're asked to sketch a graph of where the function is positive, meaning where is the volume positive? Well, here's the volume. It's represented by this function. So for what x values am I going to have a positive volume? And to do this, we can just simply think about, okay, well, let's graph our function and let's isolate where it's positive. So the first thing we want to do, of course, is in graphing a function, we want to know what's the basic shape of our function, right? There are two things, right? I want to know the shape, and the second thing is I got to know the roots, right? It's very simple. So what's the shape? And you might be very tempted to say, well, it's a cubic, so it'll look like this. Basic shape, something like that. But note that the leading coefficient is negative, and if I'm using only this function here, I would have to just think about real quick, well, this is cubic. I'd have to think about how I know it's cubic. This is a squared times a single degree, so it'd be cubic. And what would the leading coefficient of my cubic term be? Well, I'd know that it would come from this multiplication, so it'd be negative 2. So that's why it's helpful to maybe multiply it out. So it'll be reflected, so the basic shape will have something like this. The end behavior will go positive as I move to the left, and will go negative as I move to the right. So the basic shape here, I can just give myself a quick sketch. It's not the best in the world, but it gets the job done, knowing that I will be moving upwards to the left and downwards to the right. And then the second part are the roots. Right? What are the roots of my polynomial? Well, I look to the factors here, and that's why this version is helpful, because here I'd have to actually factor it out again. Luckily, I've already done that. Right? I have here one linear factor, and then here two linear factors. So the first linear factors, since they're the same, they will both be 0 at the same point. What will make this factor 0? Well, it's pretty simple. It's 0. What will make the second factor 0? So this is not just some, normal linear factor. And what I mean by normal, I guess, is you might think of, x minus 2 or something like that. Right? Very simple. Obviously, the root that is given by that factor would be positive 2. But here I'm dealing with what will make 9 minus 2x 0. And this isn't too hard. We can do this in our head, actually. 9 minus what is 0? 9 minus 9, right? So what will make 2x 9? What x value will make this right side 9? And so I'm just asking, twice what is 9? Well, half of 9 is 4.5, so twice 4.5 will be 9. So the missing value I'm looking for is just 4.5, because 2 times 4.5 is 9, and 9 minus 9 is 0. So I'll come out here to 4.5, and there's my second root. So those are the two roots. Make sure you think about what's going to happen at those roots. So at the root 0, this factor is squared, so it's going to have to bounce off. Either bounce off this way or bounce off this way, and at 4.5 it will cross through. So now let's put the two together. I know it's moving upwards to the left. It's going to have to bounce off at 0, so it'll bounce off. Then it will have to pass through at 4.5, and that makes sense because it will have to continue moving negatively. And so the question asks, well, what part of this function is where the volume is positive? So let's first look at the obvious. Clearly, it's not positive here. All right, so I can just kind of get rid of that part right there. And I could maybe try and... There we go. Okay, it's not positive there. What about over to the left of 0? Well, to the left of 0, this is saying when x is negative. Well, if you had a negative length, you would have no box at all. And so we can actually just go ahead and get rid of, we don't really even want to think about this piece to the left. What we're worried about is everything between 0 and 4.5. That's where the volume is positive. All right, and so whenever x, and the way to interpret this now is to say, hey, whenever x is in between 0 and 4.5, my volume is going to be positive. And so that would be very helpful. Now you know that your choices for x are anything between 0 and 4.5. And you might wonder, why stop at 4.5? Well, think about it. What would happen if you were greater than 4.5? To consider what you would have an x value of 5. Well, then you'd have 5 feet, 10 feet, 15 feet, 20 feet, 25 feet, 30 feet, 35 feet, 40 feet. What's the maximum amount of lumber you can have? 36. So if x were greater than 4.5, you would end up with not enough lumber to even build a crate. You'd already run out just taking care of your x lengths. And in fact, 4.5 is the cutoff mark, right? If you put in 4.5 for x, what would your volume be? Be 0, because 4.5, just in considering the x values, would take care of all of the lumber you have, and you'd have nothing left for your y values.